One thing I haven't covered in great detail so far is the grouping feature in the program. We're still at the early days of this particular feature, but it's worth showing off some aspects of it and also pointing out some weaknesses. So let's say I want to group, this is, by the way, the Lorentz equations from meteorology. So what I have here is a model that gives us turbulent flow in a very stylized model of fluid dynamics, and the equations of the system are saying the rate of change of the x variable is y minus x multiplied by the constant a, and that's shown over here. So I have that's x. It's basically the way you read a differential equation in a system dynamic program is by working backwards, and so that the rate of change of x is a multiplied by y minus x, which is what you can see over there. The reason that system dynamics programs like Minsky use integration directly rather than differentiation is integration is inherently a more stable numerical process. But of course, when we actually then display the mathematics, I just might as well do that now. Let's output the latex from this and call it Lorentz. And then go and load the TeX file. To make it a bit larger. Hang on, wrong key. Wrong key again. And then let's just move that over here and compare that to what I've got in the text file I'm working on over there. And you can see the equations are the same. So by creating the flowchart in Minsky, you replicate those equations. And if you haven't ever seen them simulated before, I'll just slow it down a bit because it's a fairly fast simulation. This is what you get. The classic strange attractor. There's an equilibrium there, an equilibrium here, an equilibrium there, and the system is repelled from all three, attracted and repelled. And you simply can't see, well, you can, for some range you think you can predict what's going to happen next. Let that run for a while. I think you can see where the idea of the butterfly effect came from when Lorentz first saw this potential model. This is actually a three-dimensional model. You're seeing a two-dimensional projection of it. At some stage we hope to, or we will, if we continue getting funding, we'll produce a three-dimensional plotting tool so you can see this in all its three-dimensional glory. But that's a pretty good start there. Okay. Let's say I want to group some of this. Well, what I do to group something is I choose a lasso, and I then go outside the region I wish to enclose and drag, he says. Where's the bounding box got to? Aha, let's go that way. Okay, I'll just do one, probably didn't do that. I'm just going to run my bounding box so it catches the X there, and that's important. Didn't quite do it properly, I just ungroup that. Let's just pan this a bit and move it away from the edge there so I don't get those things in the way, and I'll just try that again. So do lasso from here. And I'm going to lasso it to the stage that I include the X. Notice the X has now been made part of the output of that box there. So, whoops, and this is one thing I meant to show that in a second, doing it by accident. You can move, I'll just move this down a bit here. You can move objects inside a group if you're not actually, let's move it right down here just to illustrate. In a lot of other software packages like VisSim, VenSim and so on, you've got to open up a separate window to be able to edit any group. We thought we'd be a bit clever here and enable you to be able to edit something while it's still inside a grouping box, so long as you can actually see it. I'll make this a bit smaller, and at some point, okay, now you can see that you can actually see the shape there. Our default shape takes over. But if I again zoom in a bit, then those objects become visible and I can edit from within the group. And I'll just actually make it a bit smaller again and show you one little useful trick again. If I right click here and choose zoom to display, then I instantly go to the scale where I can actually see the bits and pieces and work on the program. So that's the beginnings of grouping. Make it a bit larger here. I'm sorry it's making it look like a mess at the moment. That's because we still haven't finished writing the code to put a bounding box around the outside of the plots and set up the labelling properly and so on. But hang on, pan, go back to move mode again. I'm looking forward to getting context sensitive motion here. So that's a way of grouping. That's useful if you have a fairly complex system and you want to, for example, just hide the complexity by having, go to zoom back in again, objects like that, which you can then go inside and check out later, rather than looking at all the various bits and details. Not particularly necessary on a small model like this, but I'll just illustrate a few features of the grouping there. So notice you've got the X variable there. Let's say I edit X. If I right click, by the way, and I'm X, then I can edit the actual object. Right click here, I edit the actual bounding box. Like I can resize it, for example, make it a lot smaller. And click here and right click and choose where's edit, okay, and call this X variable. In case there's lots and lots of complexity that you wanted to hide when you're working at a particular level. And there goes, choose zoom to display you're in there. Notice the X variable will probably work to move that particular piece of text out of the way so it doesn't obscure what you're working on. So go back here, actually back to the 0 scale. So that's the beginning of grouping. Now I can, once I've got a variable like that with the X there, I'm just going to delete this X and wire this output up to the multiply block there. And move this X over here. And I've got the Y and the Z there. Now, it may be what I can also do, if I want to lasso this, I can lasso both the inputs and the outputs. So they're both shown. Whoops, pardon me. So I'm now showing this is an output of the X variable into here. There's the Z variable. Well, I can remove the Z, for example. Delete that and wire directly from this Z. This is looking, particularly ugly. I'm just showing some of the potentials that exist in grouping. Okay, let's delete that. Let's actually just try to embed this in there. And now I've embedded that Z as an input into that system. Now, of course, this is a pretty dreadful demonstration, but the basic idea is if you are carefully designing a model that gets extremely complicated, then you can hide that complexity using grouping, which is the whole function of groups, just to hide complexity. That's a mess, I won't save that, but I'll just open up the debt deflation model to show you where I've actually used it more sensibly. And for example, here I've got the price level. Now what is the price level? Let's zoom in. And you then see it's an equation which is in fact derived by working out the level at which you would get an equilibrium price given a flow of demand, money demand coming in, and a flow of physical supply coming back. So it's actually ends up in some ways integrating a neoclassical vision of supply and demand setting prices, but in a post-Keynesian perspective where it's non-equilibrium. And what I get out of it is actually Kalecki's pricing equation for those who know Kalecki. But that's, that complexity would be a bit of a mess if I had it shown on full scale on the diagram here. Equally, the wage function, which is the Phillips curve, zoom in and check that out. Now that's a lot messier. What that actually uses a generalized exponential equation, as is the one down here for the investment function. So let's zoom in and take a look at that. Pan up so you can see it more clearly. So just to mean that sort of stuff doesn't physically distract you, you can put them inside a group. And we also support groups within groups, etc., etc. Now one little problem we have, and I'll see if I can illustrate it here. Okay, I'll just create a group here. So I'm grouping prices and, we'll start. You can see that the two elements have turned around the wrong way. I'm going to edit this one, and rather than PK there I have a ridiculously long variable name. And you can see it's making a bit of a mess of the whole thing. So what we intend doing in the next release, the MUN release, we'll replace that with a a maximum length for something which has been embedded as an output from a group, and then a tooltip to show you what the full name is. So play with grouping, give it a try. You can do a hell of a lot without it, as you can see from this particular model. In that, well, it won't work now. Well, actually, I'll reload the original. Let's see. Go back to the original here. And just make it a bit smaller so you can see the whole thing on screen. This is a set of equations to cover the financial sector, apart from this one over here, which is the re-lending function and the investment function. Zoom out. There's quite a bit of complexity in the overall model, but it still fits reasonably well on a single screen. And if we simulate, we get the debt deflation that I've shown in a previous presentation. So I did need to group these, but I could actually have had them up there on the screen and had quite a complex model. But it would just been the detail of seeing each of these, well, particularly these three, generalised exponential would have been too messy, so it was easier to just summarise them by putting them inside a group, and I'm showing that the input to the Phillips curve function is the employment rate, the input to the repayment of debt is the function as the rate of profit, the input to the investment function is the rate of profit, and the outputs are the wage function, a Phillips curve function effectively, the profit, the repayment function, tau r there, which is the lag for repaying debt, and the investment function out here. So that's the role of grouping. Hide the complexity when you don't want to see it, but still make it possible to dive in and check it out at a later stage. When we get to the point of designing very large-scale dynamic models of a monetary economy and try to fit it to data and so on, then there would be lots of groups being used to hide the complexity of different sectors, different inputs and outputs and so on. So that's grouping. Now, what else have I got on my list of little things to show here? Okay, zooming I've shown. I'll just zoom again, try zooming again. This is zooming in the overall scale of the model. And this, of course, is zooming just to display a particular sub-item. Reset the zooming. And the next one is bugs. I'll stop there and go on to bugs.